Hi everyone. So my name is Rebecca Franks and I'm a developer relations engineer at Google. And today I'm going to be talking about custom drawing in Compose. So I'm so glad there was some Compose love earlier because it would have been a little bit awkward if there wasn't. But yeah, today I'm going to be speaking about graphics. And for those that may have watched the custom layouts and graphics presentation from ADS, this presentation might be somewhat familiar to you, as I was supposed to do a talk with Simona, but unfortunately couldn't make it. So this is kind of considered like the extended edition of my talk, with deeper dives into some other concepts. But you should totally check out this talk as well, because I'm not going to cover the layout stuff. But yeah, let's get into it. So we've probably all seen some pretty cool custom graphics that are used in an app, or you've had your designer come to you with some fancy animations and you're just like, I don't know, I don't know where to do that. I don't know how to implement it. So hopefully by the end of this presentation, you'll know how to start creating your own custom drawing in Compose, or be inspired to go maybe read the docs or look at the code that's shown in this examples. So the first example that we're going to be looking at is a new sample of ours called Jet Lagged. And this is a sleep tracking sample which shows a graph of your sleep data over time. So how much you've slept in a different sleep period, like awake, REM, light, deep sleep over time. And this is a pretty complicated UI. And so you might be wondering, why would I choose to do a custom layout or custom drawing for this? Couldn't I just use a basic row and column to get to this same point? So if we analyze this design, we might notice that it's quite detailed, and the offset and size of each of the rectangles for this graph is based on the duration of the sleep period that is being shown. So we have as custom design, the rounded rectangles of this graph are connected together with lines in between the periods, and there's a gradient that's expanded across these bars. So we've determined that this is probably not going to be easy to do with rows and columns. So let's get into how we can draw something like this in Compose. So to draw something custom in Compose, we have a few different options. We can either use a canvas composable, or there are 3 different modifiers that we can use: draw behind, draw with content, or draw with cache. So if we take a look at the canvas composable, we can use it to execute drawing commands. We'll get into the depths of what kind of drawing commands you can do, but a quick peek under the hood of how the canvas composable is implemented, we can see that it may just notice it's just a spacer in disguise, using modifier.drawBehind. It's wrapped in a conveniently named composable called canvas, and we can then just basically not look at this because it's the same thing as draw behind and draw with cache, that kind of thing. So we can just focus on these 3 modifiers instead. So looking at these 3 modifiers that are available, we have modifier draw behind, which draws the content behind your composable; modifier draw with content, which allows you to specify the drawing order of your calls; and modifier draw with cache, which allows you to cache the objects that you've created inside your modifier until the size or your state variables that are read inside are changing. So we know what modifiers we have, but let's quickly understand how things are positioned in Compose. Coordinates start with the 0, 0 position at the top left, equaling 0, 0. And the bottom right is the coordinate of width and height. The y value increases as it goes down, and the x value increases as it moves to the right. We also need to keep in mind that all draw and layout calls that are performed in pixel values and not in DP. So therefore, in order to draw something consistently across screens, we'd want to convert from DP to pixels to make sure we're drawing correctly. And something that's also relative for Compose is that when you are drawing something with modifier.drawBehind or DrawScope, you are also relative to the parent composable that you're placed in. So if you're placed inside a box that has a height of 100 by 100 pixels and has an offset of like 200 by 100, you will be in that drawing area with that offset and mapping to the 0, 0 point. So back to the graph that we're trying to implement. The bar that we are going to implement is called a sleep bar, and we will use a spacer with modifier draw with cache to draw it. We are using draw with cache because we'll be creating things like a gradient brush and path objects that we want to cache for our drawing to be faster. We can use any composable here for drawing. We've chosen to use a spacer because we won't have any other content that's going to be drawn on screen, so it's just going to be a blank composable. So now in this onDrawBehind function, we have access to DrawScope. And it may look like we don't have a canvas that we can call commands on, but inside the DrawScope, you can execute different drawing methods. So what is actually the DrawScope? It's Composer's answer to declarative stateless drawing. So this allows you to call draw functions without needing to maintain your own canvas state. So it's a much nicer API than previously when you had to use the canvas to call save and restore. You don't need to do that anymore with DrawScope. So taking a quick look at the definition of DrawScope, you'll see it has a bunch of methods used for drawing. We can also get access to the size and center of the drawing area, and this will be useful for adjusting the size and position of an item when you're drawing it on screen. So now we know what we've got access to. We can replicate the rectangle that we had initially. So to do this, we can just call draw rounded rect with a gradient brush that gives us this fading yellow effect across the bar. We could also just call draw rounded rect with a color or solid color. There are multiple overrides here that can take both brushes and colors that you can use. So one thing to note here, because Compose uses Kotlin, you can see that we used the draw rounded rect function, but we didn't say the size or the position of where it is going to be. So because it's using Kotlin, it's got the default values set, and that's actually a pretty useful way to use Canvas with these default values. The top left is set to 0 as the offset, so the 0, 0 point, and the size is set to the whole size of the item, offset with the top left size. And you'll notice all of the, or most of the draw functions on DrawScope have these defaults set. So if you're calling draw without setting any of these values, you're probably going to take up the full size of the composable that you're in, and it's going to be positioned from the top left of your component. So this is really useful, but if you want to start adjusting your positioning, you will see then that you'll have to then start using that coordinate system that we talked about. So running this code, we can see that the sleep bar is now done, and it is drawn in a rounded box. Yay, rounded rectangles. So the next thing that we need to draw is the sleep score emoji. So this is just a text emoji, so we can learn how to draw text in DrawScope. And this has been added in Compose 1.3. LA is very happy about this, to cater for drawing text. So back to our code. In order to draw the text on the canvas, we can create a text measurer, and we can remember text measurer, and measure the text that we're going to draw. We provided the string that we want to draw. In this case, it's just our emoji string that we're going to draw on screen. And we call measure with draw with cache, and to measure the string that will be drawn on screen. We then call draw text with the result of measuring that text, and this will draw our text at the 0, 0 point on our canvas. We can customize other parts of the text, such as the alignment, size, set a brush, do some cool animations, but we have just a simple emoji here, so we don't want to do anything more. So now we have our emoji, yay, on the bar, and this is looking good so far. But looking back at our design, we have the non-expanded state implemented, but now we want to implement the expanded state. So this complicated place. This looks like a pretty complicated design, but the first step that we can do is to increase the height of the sleep bar on click. So how do we do this? Well, we want to animate this height from 0 to a certain amount of height, or from 48 or something to a certain amount of height. So we are required to create an animation variable to keep track of this. So we create a isExpanded variable, a state variable that we keep track of, and we toggle its state on click of the item. Now to use this expanded state with an animation, we can create a changing height value. We create a transition object that we then use to coordinate multiple properties that should be animated when the expanded state changes. And in this case, we're just animating the height of the item on click. Great. We now have the size of the bar that's increasing on click of our composable. So this is almost there. We need a few more steps, though. The next thing we need to do is to do the text offset. So the text needs to move with the expansion. So back to our code. We can create a text offset animation using the same transition object that we defined before. And in this case, we're going to animate between a 0 and 1 value, depending on if it's expanded or not. So if the text is expanded, we're going to animate its movement using a translate function. And this will translate everything that is drawn inside the lambda of this function. So we move the start of where the text will be drawn to the full width of the measured text. So basically inverting the offset to move the whole text off the bar that is drawn on screen. So it's worth noting, draw text also has the option of setting like the top left offset for where it should be drawn. But in this case, we're just going to use the translate function to achieve the same thing, but it's the same at the end of the day. Great, so the next part, the most complicated part of the whole graph, is drawing the paths that represent the sleep periods. So this expanded state, as we've seen already, has different types of sleep spent in different periods. So awake, REM, light, and deep sleep at different heights of the whole bar. And these rects are rounded and a gradient is applied across all the bars. So back to the code. Instead of just drawing that simple rounded rect that we were drawing before, we will draw a path that we're going to generate by iterating over each sleep period within this data. The path will then be used, the same path will be used for both the expanded and the non-expanded form of this graph. So for each sleep period in a day, we should check if there is a previous sleep period. We keep track of this variable over time, and we iterate if there is a previous sleep period. So if there's a previous period, we call path.line2. And this will draw a line between the start of the previous sleep period and to the next sleep period that will be started. The next step is to add the current sleep period as a rectangle to the whole path, to the path that we're going to draw. And the size and offset of this rect is calculated depending on the duration of the sleep that you're in, and each bar gets a vertical offset dependent on which type of sleep you're in. So after we've added that, we then call path.moveTo. And this moves the path to the start of the next line to draw. Path.moveTo doesn't add any actual output to your path command that you're generating. It is just an instruction of where to start drawing from in the next section. So this process is then repeated for each sleep period, building up the path that we have on screen. So it's drawing a line, then a rect, then moving the point, drawing a line, then a rect, and moving the point again. Cool, so we have our path that we've generated, and now we can just call drawPath with it. So we call drawPath in our DrawScope that we have applied before, applying the vertical gradient brush that contains the different colors. Nice, we have our bars that are being drawn, but there's no lines in between them, unfortunately. So what's going on here? So the default for draw style is to draw it with a fill. We saw all those default arguments. Because we didn't specify what kind of drawing it's going to do, it is just using a style of fill. But in order to get the lines, we need to call it a draw path again with a stroke style set as well. And we can customize many different things on here. We can set the style to have a rounded join. We can also at this point set the rounded corner based on the expanded progress of our animation. So as it animates, it expands the corner path to be less rounded than what it is at the start. And there we have it. It looks a lot more like what we were expecting at the start, and our lines are drawn in between each path item. So we have our sleep information that's now shown on these bars, and it's worth noting here that the height animation that we have before is the same. It's not any different. The only difference here is that we are animating between these two states. So the first state, the non-expanded form, has the same rectangle, but the height offset per sleep period is 0. And it expands to the offset per sleep period as it expands. So it's the same path, just contracted or expanded. Great. So the next thing we want to do is to make our background of this app a little bit more dynamic. We'd like to add some like wavy movement bars at the top, and we're going to use some shaders to achieve this. So previously, to use shaders on Android, we needed to use a surface view with OpenGL. But now with AGSL, shaders can be easily incorporated into DrawScope drawing calls. So AGSL stands for Android Graphics Shading Language. It is based on GLSL, and it runs on Android T and up. And shaders run on the GPU, so it can be very efficient to run it as your pixel calculations are run in a parallel way. So typically when you're building something with shaders, you go onto an online shader tool like ShaderToy, for instance, and you browse around, or you're really good at maths and you know how to write them yourself. But basically, we've got this cool shader that we've defined or found online from ShaderToy, and we want to put this in our app. So looking at our code, on the jet lag screen, we want to draw this shader as a background for the top section of our app. So to define our shader, we take this mostly from ShaderToy. I left out the bits of the complicated maths. But this is a basic shader that you would add, which runs for every single pixel. So this main function is called for every single pixel of your composable that is drawn on screen, with the coordinate, the frag coordinate for the X and Y position that it's being called on. So this shader that we've defined, we're going to hook up into our composable that we're going to execute the shader on. So we're going to use modifier draw with cache, again, on the column, as we want to cache our shader and the shader brush that we're creating. So we create our runtime shader, giving our AGSL string that we've just created as input into it. We create a shader brush, giving the shader as input into that. And then we set a uniform on a shader. So for those that haven't done shaders before, basically this is a variable that you're setting in your fragment shader that we've just created. In this case, we're setting the resolution, which is the width and height of the composable that we're in. And we're sending this as input into the shader for the whole shader to run, not for every single pixel. So once we've done that, we then call drawRect in our onDrawBehind function with the shader brush, and this will draw our bars, or it will execute the fragment shader for this area that we're drawing on screen without any movement. So this is the result of it. It might be a little bit hard to see at the back, but basically the static result of calling drawRect with our shader, there's no movement, but the bars are appearing on screen from this small bit of math that we've added. So in order to add some movement to our shader, we need to create an animation and pass the animation time into our shader. So we create a time variable that increments itself using with infinite animation frame millis, and this will be updated on every single frame. When that uniform variable, we then set the uniform variable, so same thing as the resolution. We are now setting the time variable, but this one we are setting in every onDrawBehind call, as this is going to change. And this will constantly be updated on every single frame. So let's take a look at what this looks like now. Hopefully you can see that, but basically this takes, our shader now is taking in time, and the wave effect is applied, and the bars are moving, and you should be pretty mesmerized by this right now. Okay, so we've built a pretty good looking app. I'm pretty happy with what we've got, but now we can start to dive into playing around and making things that we probably won't need to use in production, but they're fun to know anyway. So we've talked about DrawScope and how you won't need access to your canvas. You can just call draw functions, you call translate, and everything's managed for you. But if you've used Canvas before, you might want those save and restore methods that you had before with Canvas. So we can do it, and we can access our canvas, and we can see how we can do that in Compose. You shouldn't really need to, because most of it's exposed, but if you do need to, it is possible for you to access it if you want. So in this example that we're going to do now, we'd like to have our app have absolutely no life anymore. We want to desaturate the entire app and remove all color from it. So looking at the DrawScope methods that are on there, we can see there isn't a way to set a color matrix on all our content. So we need to reach into a canvas to do this. So we will use modifier draw with content here and alter the content drawn on screen with our composable. We call draw content as this will invoke the actual drawing of the composables that we want to draw on screen. For example, in our jet lag screen, we have the graph, we have everything, we have our text, our background, all of that's going to be already drawn. And now, to change the saturation of our content, we can create a color matrix and set the saturation of the color matrix to 0. And then we set the color filter on the color matrix of the paint that we've created. If we remember Canvas Paint. We then call draw into canvas, and this method gives us access to the canvas object if we need to have it. So at this point, we can call things like save layer, which is what we're doing at this point, and we're setting a paint with our save layer. So as we set this paint, it basically means draw everything in this layer that we're going to draw from this point on with this paint that is desaturated. So we then call this draw with content, or draw the content itself. So we've set the paint to desaturated, we call draw with content, and then we restore back to the point before we had set the paint on it. And now we have an app devoid of all color. We could play with some animations to maybe slowly suck the life out of it, but I'll leave that up to you to try if you want to. Okay, so we were using draw with content, and I didn't really get into what exactly you can do with it. But the basics of it is that you get access to determine the drawing area, or the drawing order yourself, not area. So it's useful for a bunch of different things. It allows us to determine the drawing order, but also gives us access to call draw when we want to call it. So we can do many different things on it, like using different blend modes, or we can do transformations on the content ourselves, like if we wanted to clip it to a fancy path, like a star shape or something like that, we could clip our content in that way. Or we can just draw on top of the content, or behind, your choice. So in this example of draw with content, we are creating a flashlight kind of effect that is peeking on top of our UI. And all we're doing here is drawing the content, calling draw content, and then drawing on top of it with a radial gradient brush, which has got a transparent middle color and a black color for the rest of it, and then changing the pointer offset of where the radial brush is drawing on. And that's some of the kind of cool things you can do with draw with content. The next interesting modifier is modifier.graphics layer. So modifier.graphics layer is powerful, is a super powerful modifier that allows us to do many different things that, to composables that are already drawn on screen. So it allows you to apply transformations to your content, such as the scale X, scale Y, or rotations. And this is the preferred modifier to use when you're animating multiple properties at once, because it applies the changes that you're doing to the draw phase of composition. So it doesn't change anything in the layout phase of composition, and it makes it a way less expensive operation to handle when you're doing it at the later stage of the life cycle of Compose. So it's worth noting, because it is affecting the draw phase of your composition, it doesn't change the layout of your composable. So if you're scaling something up or rotating or changing the translation, the placement and size of your item that you calculated from your layout phase isn't affected. So you might have things that overlap one another or like scale above something that is already drawn on screen. That's because this is doing it in the draw side of it. So in this example, we have an image of a sun at the top of our jet lag screen in the corner, and we want to rotate it with an animation. So we create this infinite transition, and we create a rotation value between 0 and 360 degrees to rotate the sun over time. And we give it an infinite spec. But we're not using this value anyway just yet. So in order to use it, we can then apply a rotation z value using modifier.graphics layer. And this will update and rotate the animation automatically for us. And the sun should be moving on screen. Yay. Okay, there's many other transformations that you can do at the same time using graphics layers. So these are a bunch of the examples that have just been put up on the docs, new docs that we've created for graphics layers. So be sure to check it out if you want to change something else or see what any of these do. Cool. Render effects. So remember the AGSL stuff we did with the shaders at the beginning with the cool wavy bars? So we can also apply a render effect or an AGSL shader to content that is already being drawn on screen. So we don't have to create new content using AGSL shaders. So you can also do things like a blur effect, but in this example we're going to have a look at is using a runtime shader, which is also AGSL that we've already looked at. So we have this jellyfish that we are drawing on screen, but we want the jellyfish to wobble because that's what jellyfish do. And to do this, we can apply a render effect. In this case, we're going to create an AGSL shader called Wobble Shader. And this is basically a math transformation on our pixels, okay? I wouldn't be too concerned with exact math of what's going on here, so don't stress too much when you're seeing all this code on screen. But basically here, the bit to note is that what we are calling is the uniform shader contents here. So this is the important part of this particular shader, because what this gives us access to is the contents of the composable that are already being drawn on screen. So if you're drawing something like a bunch of text, or you're drawing an image, you don't even have to be drawing this yourself. You can be calling any composable that is already drawn on screen, and you can get access to that within a shader that is already, in this case, we are putting access into this, this shader will get access to it. So we can then call, on this shader, the next interesting part is that we call contents.eval with a coordinate of where we want to evaluate and we'll get the pixel color for that XY coordinate that will be on that screen at that point. So in this case, we've transformed our XY, or UV in this case, and this will get us a different pixel, but of the same composable that's being drawn already on screen. So it'll just map it to a different point and give us, I don't know, a wobble that we've applied. In some cases, in this case, we're doing a transformation, but you could apply like a noise effect or something like that. So we then use this wobble shader by creating a runtime shader object, familiar from the previous slides, and we set the render effect to this runtime shader that we've created. So note the word contents here. This is where what we discussed in the previous slide. And basically it represents the current contents of the composable that is already being drawn on screen. So if you see my column that I have here, if I have content written where it says your content here, that composable that is already being rendered will be passed as input pixels in that content shader. A bit confusing, but hopefully it helps to see the example in the next slide. Cool. So not just jellyfish, but any kind of UI can be applied with a render effect. So in this case, I've applied the same, well, this is a noisy shader actually, but I've applied a shader in the same way, passing the contents of the composable that is already drawn on screen into my shader that I'll then take effect on and apply transformations onto it. So we could do many other different things here. You don't just have to like manipulate the pixels. We could just draw a completely red screen, or we could apply a filter on the current content. So a noise is just one of the examples of something that you could do it with it, but you can apply many different things. I think I saw an example of a flame burning with text drawing the flame behind it. So if you've had a look at Shader Toy or something like that, you'll see the power of shaders and what you can do with it. Great. So another property that has been added is the compositing strategy on a graphics layer. So this is new in Compose 1.4. And this refers to how the layer will be composited or put together with existing content that is already on screen. So there are 3 different compositing strategies that are now available: auto, off-screen, and modulate alpha. And if you don't know what I'm talking about, the example that I'll show you will help explain this. But basically, auto is the default mode. There's no off-screen buffer that you're rendering to. Off-screen will force you to render in an off-screen buffer. Don't worry too much what I'm saying here if it doesn't make sense. And modulate alpha will apply each draw call individually. The alpha will be applied to each draw call that you do in your graphics drawing code individually. Okay, so an example of what I mean with this. So we have a dog, and this dog is online on on Slack, and it's got some notifications, or we've got the typical use case of like showing a status indicator on a profile pic. So in this example, we want to draw this status indicator on top, but we also want to clip away a section of this, this profile pic to remove some of the pixels between the status indicator and the image. So we create an image, and we use draw with cache. So we draw the content. So the content is the actual image that is drawn on screen. And then we draw a circle, which is actually the circle that is going to do the clipping. So we set a blend mode on it to say clear the pixels that are in this circle that is going to be drawn at the bottom. So this circle, the invisible circle. And then we draw a smaller circle. I've removed the positioning information just to make it a bit clearer. We draw a smaller circle that is a color red on top of that. Okay, so this is what we're expecting with this code, but unfortunately, you will not get that. So you would get something like this, and it doesn't really make sense as to what it's doing, because what is happening here is that we are actually drawing with our, the pixel is actually, this blend mode is interacting with a buffer that is drawing on screen. So when you're drawing without setting a composition strategy, so you're setting an automatic compositing strategy. What happens is that this buffer that is drawing is actually clearing the pixels all the way down to the window background of your entire app. So if you had a translucent background on your app, this would go all the way through and you would be able to see whatever app was drawing underneath. So what we actually want to do in this case is we want to set a compositing strategy of off-screen. So what this will do is it'll take all the different draw commands that we're doing, draw it in an off-screen buffer, so not the thing that is drawing on screen, apply the blend mode, and clear the pixels in that off-screen buffer, and then composite it back with the buffer that is drawing on screen. And that'll then make sure that we get the draw circle with a background that comes through it and not drawing all the way back or clearing all the pixels all the way down to the window background. Hopefully that example made sense. Okay, last example before I wrap up. So let's talk about how we can make this hello path in Compose or in Android. So for those that aren't familiar, we have basically a path, a path that we've defined in SVG. So an SVG is basically a set of mathematical commands that instruct how to draw something on screen. So I don't expect anyone to know what exactly this would draw, but if you're generating an SVG in a tool like Figma or Inkscape or something like that, and you export an SVG and you inspect what the SVG is, you would typically look at something like this for the path data. It would tell all the instructions, and it basically says like move this, move to here, draw a line, draw this, that kind of thing within here. So we have our path defined for that hello SVG that we want to draw on screen. So how would we maybe go about doing this? So we want to draw, we've got this path that we've created, and we can create a vector painter. So we use remember vector painter, we give it a path that we want to draw on screen, and then we say, hey image, draw this path and give it to me with a gradient brush, a linear gradient brush. That's kind of cool. It's got a gradient brush and it's drawing the word hello, but this is not exactly what we wanted, right? We wanted the gradient to go across and draw and fade as the line goes. So along the path, we want the gradient to be drawn, not across the whole text. So how do we do this? So it's a little bit more complicated. Unfortunately, there's no built-in method for this, but it's not too complicated to work with. So hopefully I can help explain how this is done. So what you get on a path object is the option to flatten a path. So what this does is it takes the path and converts it into a bunch of lines that will be drawn on screen. So in this case, I'm giving it an error rate of 0.5, which is the pixel size at which the error rate will be. So 0.5 is half a pixel, so it won't be noticeable, the differences between them. And basically, we've got this path, and now what we can do with the set of lines that we've generated is we can iterate over this line or over these lines and draw them on our canvas. So instead of calling image and creating that, unfortunately it's cut a bit there, but anyway. Instead of creating an image and calling path and setting those paths, we are now manually iterating over all the lines in this path, and we're calling draw line. So in this case, we're just setting for now a solid color of black on our drawing, and we get the same output. So we've drawn all these lines that have been flattened, and it is now drawn on screen. Excuse me. So the next, if we had to change the flatten ratio, so for those that didn't really understand what I was talking about, because I'm confusing everyone, is that the flatten, if I had to increase it to 30, so this is 30 pixels, you can see that the error ratio of our SVG that is drawn on screen is now like really not exactly what we were expecting. Okay. So we've got our SVG that we're drawing on screen, and now we want to change the color values or the gradients of colors across this SVG. So how do we do this? So what we need to do is we need to get a start and end color for each line that is being drawn on screen. So we've got a function called interpolate colors that takes the start fraction of the line and the end fraction of the line and creates these two colors. We then call brush.linear gradient. And this is probably not the most efficient way of doing this. You might want to cache these brushes in somewhere, either with a remember function or with draw with cache. But for the sake of simplicity of this example, we'll just put them here for now. So let's take a look at this interpolate colors function, because that's where the interesting part comes in. So this function calculates from a list of colors as input and a progress value, the position or the color that should be returned as a result. So we have these, we calculate the progress value, we get an old color and a new color that is within our array of colors, and we lerp between them. So for those that haven't done lerp before, lerp is short for linear interpolate, meaning that it mixes between these two values. So in this example, you can see the start and end color, the start and stop are set, and we have a fraction that is passed into this lerp function. And this is used to mix between these two colors. And this will give us a resultant color that is drawn on screen. So this process is done for each start and end value that is drawn of each little line that is drawn on screen for this whole path. And this will result in us getting a gradient that is drawn along a path. So you can see the blue starts and fades and almost ends at the green color that we've passed us. Okay, so the last part we want to do is to animate this drawing of the line over time. So in order to do this, we can add a progress animatable object that will animate repeatedly to 1 from 0 every 3 seconds. Then what we need to do is to use this value, and we take this value to determine if we should draw the line that is going to be next drawn on screen. So in this case, we are checking if the total length or the fraction of the line that is starting is less than the current length of the whole line or the progress of where we should be in this whole animation. So we just don't draw the lines that are not part of that whole progress of our drawn thing on screen. And then we have it. Our path now draws based on the progress, and this repeats every 3 seconds from scratch, starting the path from scratch. And that's it. We've learned how to do some pretty custom things today in Compose. We've learned all about the different graphics APIs available to you and how to animate these custom properties as well. Take a look at the jet lag sample code if you're interested in that, or there are the jellyfish and the gradient path if you're interested in how to draw your own jellyfish in Compose. Yeah, and we have also just recently released some new graphics docs on the developer documentation, so be sure to check those out as well, containing a lot more examples on all the different modifiers and how to use them and some examples there. And that's it. Thank you.